Going back to this example, it is going to be supervised learning because you're trying to train this model on known examples where the inputs of the model or the features of the model are the size of the house, the size of the garden, and the number of the rooms, and the labels, or otherwise called the output, is the price. So you see the labeled examples, or the examples that you're using to train your model already have the price, so which is the label. And then you train your model so that a new example that doesn't have price, the model can help you get that price. So you can see it is, you're training your model on already a data set that has labeled examples, okay? So predicted labels can be numbers or categories. Okay, so for example, we could be building a model that predicts the price of a house, implying we want to predict a label that's a number. So here they're just trying to introduce you to the concept of regression and classification. So I'm going to say this. I'm going to be very repetitive so that I can drive the point home. So you have to try and bear with me if you already know these things. Okay, so the predicted labels can be numbers or categories. So for example, we would want to build a model that predicts the price of a house, implying we want to predict the label, to predict a label that's a number. So in this case, we would want to talk about a regression model. So a regression is when you want to predict a label that's a number, okay? Otherwise, we may want to define a label that predicts a category, like cat or not cat. So something categorical, based on given features. In this case, we'll talk about a classification model, and we're going to delve that deeper into that. So this is just a simple illustration of supervised learning. So we have a set of features, and then this is, I think, the model, and then these are the labels. So supervised learning models associate a label with each data point described by its features. A supervised model is trained on labeled data set composed of examples of pairs, features, and labels. Okay, so these are the features and the labels, and the supervised model is trained on this data set that already explicitly has these features, otherwise known as inputs, and their respective labels, or otherwise known as the outputs. All right, so we just talked about briefly what supervised learning is in terms of it being trained on a labeled data set. And now we're going to break down supervised learning. Okay, sometimes you want to predict an actual number, sometimes you want to predict a category, like whether it's falls in this category or this category, like it's binary like that, okay? So when you want to predict a number, we're going to see that that is what you call regression, and we'll need to talk about regression models. And then when you want to predict something that is categorical, that falls between like different categories, we will see that that is what they call classification model. Okay, so regression model here, we see that the features, using the features, you use the model to predict a numerical label. So this is the regression. And then for classification model, you use the features to predict whether a certain something falls between different categories. So regressions try to predict a numerical label, a number or a vector. Classification models try to predict a categorical label, something like yes or no on iris species or something like that, okay? So for now, I'm going to share these resources so that you can read better at your own pace. But yeah, so since this is going to go into unsupervised learning, and that is going to be covered by someone else, we're going to stop there and then go into what are the real business use cases for supervised learning. So you're in this class, you want to write code, but you want to write useful code. You want to write things that will really help you in your job, okay? So that was a simple introduction. What is machine learning? What is supervised learning? And under supervised learning, there is regression and classification, okay? So that's just a simple introduction. So now we're going to go on to how we can use these algorithms in our day-to-day work. Okay, so but some of this stuff is going to be repetitive, like I've talked about it in the previous blog, but it will be helping me drive the point home. All right, so again, so this is V Sharma, and they are trying to define supervised learning. So let's just read through it and we see. So supervised learning, a blessing we have in this machine era. It helps depict inputs to outputs. It uses labeled training data. So you see again, this is key, that supervised learning uses labeled training data. So the introduction, the word they've introduced here is training. We hadn't looked at training and testing, but we shall look at it. So this is labeled training data to deduce a function which has a set of examples. The majority of practical machine learning uses supervised learning as on date. Okay, so not very well written, but the whole point is that supervised learning uses labeled training data to deduce an output, and a lot of practical machine learning that is being used in industry, at least, uses supervised learning. Okay, so they try to define machine learning. You'll find that with your research, there will be a whole lot of definitions of machine learning. So this one says that AI Lab page defines machine learning as a focal point where business data experience meets emerging technology and decides to work together. Okay, that one is just like a very high level, like very high level definition, I think. But yeah, it makes sense. You want to talk about business. So a focal point where business data, of course, now business will provide data, and then experience will provide like maybe the logic that you want, which will help you maybe choose a model. Meets emerging technology. So emerging technology is that we're going to be using these algorithms that have been written, and Python, and yeah, all these technologies that are out there decide to work together. It's very high level, but I don't know, maybe you can tell me what you think about it. All right, so machine learning is also a subset of artificial intelligence. I think this might have been covered before, but yeah, and it borrows principles from computer science and statistics, which is a graphical branch of mathematics. Okay, so it instructs an algorithm to learn by itself by analyzing data. So like we said in the previous blog, you're trying to you get an algorithm and you get it to learn the coefficients by giving it several examples of data, and then that algorithm is going to do what? Analyze the data and try to learn from the data. So the more data it processes, the smarter the algorithm gets. Until only recently, even though the foundation was laid in 1950, machine learning remains largely confined to academia. Sadly, it's becoming more accessible to developers as their tool. I don't know why that's sadly. What we need is simply machine learning as a service for everyone. So this is just an opinion point, really. Okay, so let's go to the more interesting things, I guess. So the different types, we've already seen that there's a difference between supervised, unsupervised, and semi-supervised learning. So here the new thing is semi-supervised. It's not so common, but just for your information, semi-supervised is a mixture of supervised and unsupervised techniques that can be used. And as some of the data is labeled and most of it is unlabeled. But we shall see that we are going to focus mostly on supervised learning and unsupervised learning. And in this lecture, I already said, we're going to focus on supervised learning. All right, so let's go and see some use cases, like where can you actually apply machine learning? And I think this is important because you want to have reason for why you're learning this class, you're going through the hassle of trying to learn these things so that you can actually apply it. All right, so ML, machine learning, has strengthened organizations and awarded success with each type of learning. Making the right choice of the technique to be used for a business problem requires a strong understanding of the field. So yeah, you'll find that for machine learning to help you, you really need a business expert to help you understand the data, understand why you want the actual application of the machine learning in your business. Okay, so this is just saying that the business background and experience is very important to help you make the right choice of the technique to use. Okay, so evaluating which conditions are best suited for each approach is another task. Okay, and then so the types of machine learning algorithms, i.e. ML algos, and which are used and which one to be used are extremely important. So this is just, they're just trying to let you know like the different things you need to know, like a broad picture, like if you're really trying to apply machine learning in a specific use case. You need to know making the right choice of the technique to be used, okay, for a business problem requires a strong understanding of the field. Okay, so you need to make a right choice. So evaluating which conditions are best suited for each approach is another task, and then also knowing the types of machine learning algorithms to be used is also extremely important to know. So it goes beyond just learning how to technically write the code and everything. You have to really know what's best suited for which environment and having a good understanding of the business problem. All right, so So I think this is just different examples of like different fields. I think this is insure. It's supposed to be insure because insure doesn't make sense. So insure tech, so you can use premium rate optimization. You can use machine learning to optimize your premiums. You can use machine learning to detect fraud. You can use machine learning to for default reduction. Then claim automation, okay, and then automating claims that come in through insurance, then also predictive analytics, which you'll see really cuts across. Okay, in marketing, you can use machine learning to analyze click stream. You can use machine learning for recommendations, recommender systems. You can try to forecast demand. You can try to target different customers. You can try to segment your markets. Then there's 720-degree customer view. I think that's a thing in marketing. And then you want to try and optimize your ads. So within the marketing space, there's quite a whole load of machine learning use cases. You want to also optimize your supply chain, and then also social media analysis. You also want to analyze your social media. And then, yeah, so in healthcare, you can try to predict health, you assessment of patients' health, trying to do diagnostics, then also setting up alarms and alerts in case different things occur, and then also detecting fraud. Yes, so in telecos, you can try to analyze customer churn. You can use machine learning to do system log analysis because you have a bunch of logs that come in just like by the nature of telecos, or even IT. Like major like systems that are being used in different companies, they have a lot of logs. So trying to analyze those logs, trying to analyze and detect anomalies. You can use machine learning for that. Also preventative maintenance. So trying to predict something before it actually occurs. You can use machine learning for us. Then smart tech analysis. In fintech, there's risk analytics, there's credit scoring, there's fraud detection, there's payments intelligence, there's predictive analytics, okay? In cyber security, there's threat hunting, okay? There's cyber intelligence, there's blocking and prevention, there's behavior biometrics, and then also like preventive analytics. So you can see there's really a wide range of application of machine learning algorithms. You just need to know which business problem are you trying to tackle. Of course, you want to do a lot of research about that business problem and trying to see how do I apply now this knowledge, okay? So the goal of the task and all the things that are being done in the field, and to put you in a better place to break down a real problem and design a machine learning system. Yeah, so I guess this should be your goal. So